Questions 7 through 10 says determine whether each problem below represents a direct variation or proportional relationship. If it does, state the constant of proportionality, which is what K equals, and if it does not, state the reason why. Alright, so let's talk about what a direct variation is. The easiest way on a graph to determine if it's a direct variation is if it makes a line and it goes through the origin. So if we look at number 7, the origin is where your x and y axis intersect. So this is the origin, and our graph goes right through the origin, and it's a straight line. So this is a direct variation. The easiest way to determine what the or constant of proportionality is to just look at your slope. Okay, it's really just your y values divided by your x values. Okay, so if we can look at this coordinate here. Okay, this coordinate here is 2, 1, and so our k is just the y value divided by the x value, which is just 1/2. So that's one way to find it. The other way is, like I said, just to find the slope. You go up 1 over 2, so k is 1 over 2. So there's two different ways you can do that. Number 8, by looking at the graph, I can tell that this is not a direct variation because it does not go through the origin. It is a straight line, but it does not go through the origin. So I'm going to say no, and I'm just going to say the line does not go through the origin. Okay. Now, looking at a table, it's a little bit harder. You could always plot them on a graph if you wanted to, but that's just time consuming. So for number 9, we're going to look, like I said, there's a couple ways that we can do this. Both things have to happen. So it has to go through the origin, and it has to have that the same ratio. And so to find that ratio, like I said up here, it's just the y divided by the x. So we can go through and say, all right, well, 6 divided by 1 is 6, and 10 divided by 2 is 5. Well, those aren't the same. So right there, I can tell. We could keep going through and dividing these and write out what those equal. This is like 4.6 repeating. This is 4.5. This is 4.4. Okay, so they don't have the same ratio. So I know right there it's going to be no. I can say then the ratios are not proportional. So that's one reason. I can also look at the y to see if it goes through the origin. These go up by 1. So if that goes up by 1, up by 1, up by 1, up by 1. So if I go backwards, I'm going to go down by 1, which would give me 0. And these go up by 4. 4 plus 4 plus 4 plus 4. So if I go down 4, then I'm at positive 2. And 0, 2 is not the origin. 0, 2 is way up here. Right? So it doesn't go through the origin, so that's another reason. So it's not proportional, but also the line does not go through the origin. And really, just either one of those would work, because you have to have both of them for it to be yes. So if it's no, you just need to state which one, and then you can either find it this way by locating the origin, or you can find it by locating the ratio. Okay, so number 10, when I look at this one, I'm going to look at the ratio first. So this is plus 1, plus 1, plus 1, plus 1. This is plus 4, plus 4, plus 4, plus 4. So my ratio is going to be the y values divided by the x values. So we can do 4 divided by 1, which is 4, 8 divided by 2, which is 4, 12 divided by 3, which is 4. You can kind of see what's happening. They're all equaling 4. And since they all equal 4, 4 is our k value. Now, we do need to make sure it goes through the origin. Okay, it should, since these are all equal. And if we go backwards 1, we get 0, and if we go backwards 4, we get 0. So this would be yes, and our k is equal to 4.